Bioremediation technique in watershed area. In context of watershed management, ensuring water quality is as critical as conserving water. One of the promising, eco-friendly and cost-effective approaches to improve water quality in polluted or degraded watershed areas is bioremediation. This method uses naturally occurring or introduced microorganisms, plants, and biological agents to degrade, transform, or remove pollutants from water and soil, thereby restoring ecological balance. Bioremediation is based on the principles that certain bacteria, fungi, algae, or plants possesses the natural ability to break down harmful contaminants like organic waste, heavy metals, oil, and other toxic compounds into less harmful or harmless substances. Unlike conventional chemical treatment that may cause secondary pollution, bioremediation enhances the natural self-cleaning capacity of the ecosystem and is highly suitable for decentralized and rural applications such as in watershed areas. In watershed region, bioremediation techniques are often integrated into natural water bodies like ponds, streams, and recharge structures. One of the commonly used technique is phytoremediation, where plants such as vetiver grass, water hyacinth, typha, or duckweed are used to absorb or degrade pollutants. These plants can extract heavy metals from the water, absorb excessive nutrients like nitrates and phosphates, and even break down organic compounds, preventing eutrophication and improving dissolved oxygen level in the water. Another technique in biofiltration, where microorganisms are embedded in filter beds made of sand, gravel, or organic media. As polluted water passes through these filters, the microbes digest the contaminants. This is particularly effective for treating greywater or agricultural runoff in watershed zones before it reaches natural water bodies. Constructed wetlands are an increasingly popular method of bioremediation in watershed areas. These are engineered systems designed to mimic natural wetlands. Wastewater from villages, livestock areas, or agricultural fields flow into these wetlands, where aquatic plants and microbes work together to remove pollutants. Constructed wetlands not only clean the water but also support biodiversity, enhance groundwater recharge, and offer community education and employment opportunities. In some cases, bioaugmentation is used, where specific strains of beneficial microbes are introduced to polluted sites to accelerate the degradation process. These microbes may be naturally occurring or selectively cultivated for specific pollutants like hydrocarbons, pesticides, or industrial effluents. The application of bioremediation in watershed areas have several advantages. It requires low infrastructure and maintenance cost, can be implemented using local resources, and aligns well with community participation models. Villagers and SHGs can be trained to maintain constructed wetlands or floating plant beds, creating both awareness and employment. Moreover, it strengthens the integrated approach of watershed development by linking land, water, and biomass management in a sustainable loop. However, for bioremediation to be effective, certain conditions are crucial. Appropriate temperature, oxygen availability, pH balance, and the presence of necessary nutrients for microbial activity. Therefore, regular monitoring and community sensitization are important components of success. In conclusion, bioremediation presents a powerful tool to clean and rejuvenate polluted water sources in watershed areas. It transforms waste into wellness through nature-based solution and supports long-term water security. as India faces increasing challenges of water pollution, particularly in rural and semi-urban contexts. Promoting bioremediation within watershed program is a timely and a transformative step towards sustainable water quality management. Thank you.